Hello and welcome. This is going to be lecture number 11. Go ahead, put the lecture number and the date at the top of your notes. Let's go ahead and get started. So I wanted to quickly review this idea of a valence electron and how many valence electrons each atom has. So a valence electron is an electron in the outer shell, or the outermost energy level. So this first block here, we know it's hydrogen, but it doesn't really matter. We know that it's the first element and it has one electron. So that electron is considered a valence electron. Helium has two, but that first shell can only fit two. That's why there's only two elements in the very top of our periodic table. The next shell can fit 8. So we start filling in that next shell. Here's lithium, it's got 1. And then we just kind of count up on our way across the periodic table all the way to 8. And then at this point, that shell is filled and we start over again. 1, 2, 3, 4, 5, 6, 7, 8. And again. Now, in this section in here, things get a little bit strange because with these heavier elements in the transition metals, we have access to the d orbitals, which are actually a lower energy level than the outer shell. So this whole region in here, we just say like 3 to 12. But then the pattern does pick up again over here on this side of us counting up. And this is how the periodic table is organized. It's organized to have matching numbers of valence electrons. All right, so that's our review of number of valence electrons. So when we're talking about valence electrons, we're talking about atoms in their neutral state. But what are some things that can cause an atom to gain or lose electrons? I'll embed a question here for you to just think of a couple. Okay, so here's my list. So one thing that can definitely cause an atom to gain or lose electrons is a reaction. This is a really big part of reactions, is the movement of electrons. So in a chemical reaction, atoms are gaining and losing electrons all the time. What's something else that can cause an atom to gain or lose electrons? It can just be spontaneous. This is especially true for elements near the edges of the periodic table, like alkali metals and alkaline earth metals. Those two will just spontaneously lose their electrons because they want to have a filled outer shell. So if they get rid of their extra valence electrons, then their shell that's already filled with 8 electrons becomes their new outer shell. Likewise, halogens will just spontaneously gain electrons if they're available. Another way would maybe be electricity. So electricity or any sort of high energy environment can just knock electrons off of atoms. Another option would be acidity. A very acidic environment is very poor of electrons, and so electrons will just move away from their atoms in a very acidic environment. Perhaps you can think of some more. There's lots of different ways that atoms can gain or lose electrons because the electron is just on the outside of the atom anyway, just moving around can just easily be gained or lost out here. The nucleus never changes, but these electrons, they're just very vulnerable, can easily be picked off. And an atom can easily gain extra electrons. So like I was starting to say in that last slide, is that atoms, they want to look like noble gases. The noble gases are over here, and noble gases all have a perfectly filled outer shell. So noble gases don't really ever gain or lose electrons. They are fine just the way they are. But every other atom wants to look like the noble gases, so it will readily gain or lose electrons to have a filled outer shell, which is considered more stable. So hydrogen's kind of a weird one because it can just lose its one electron and take on a +1 charge, or it can gain an electron to look like helium and take on a -1 charge. All right, so the -1 charge would be the fact that it has 2 electrons and 1 proton, and the electrons are outweighing the proton by 1, or the +1 charge would be the hydrogen atom is literally just a single proton. All right, helium doesn't want to charge at all, so it's just going to be 0. Lithium wants to look like helium, so it'll just lose its 1 electron and take on a +1 charge. Same with beryllium, but it has 2 to lose, so it'll just lose them both. Now, as we get over onto this side, we can keep losing electrons. Boron will lose its 3 electrons, but this next one is carbon, and carbon has 4 valence electrons. So if carbon wants to look like a noble gas, it can either lose all 4 of those and take on a +4 charge, or it can gain 4 more. There really isn't a preference here for carbon. Maybe there's a slight preference towards being a +4 versus a -4, but it's the same distance to look like a noble gas. And then it starts counting down as we get closer to this noble gas here of neon. Next up, we would take on a -3 charge, gain 3 electrons to fill out the outer shell in nitrogen here. Oxygen gains 2 and takes on a -2 charge. Then we got a -1 and a 0. And so not every atom is going to gain or lose electrons, but this is one way for them to be more stable. It depends on the environment, what's happening around the atoms, what sort of chemical reactions are available. But this is what drives a lot of chemistry, is this desire for every atom to look like a noble gas, and so it will gain or lose electrons to make that happen. This next row is going to look the exact same. Elements on the left side will lose electrons and take on a positive charge. Elements on the right side will gain, and then right in the middle, they can kind of go either way. And even these +3s could actually be -4s, or this -3 could be a plus or a -5, or this -3 could be a +5, because they could go the other direction to get that extra charge. So that's a +4 and a -4, -3, -2. It's supposed to just match right above, and it continues. Now, in the transition metals, again, it can be kind of strange in here. There's more ways for them to fill their outer shells. Often they will take on a +2 or a -2 or a -4 charge. But a lot of different charges are possible in here. But then again, the pattern picks up on this side back in the main group with +1, +2, +4 / -4, -3, -2, -1. And then the noble gases are always a charge of 0. They don't want to gain or lose electrons. So again, these are just common charges. Nothing here is 100% the way it's going to be in a reaction. We can still have some charges that are different than these, but these are the most common. All right, a few common ones to memorize. They are the far edges of the periodic table. We should know that sodium is going to almost always have a +1 charge. It just loses its 1 electron. Calcium almost always will be a +2. Oxygen is almost always going to be a -2. And chlorine is almost always going to be a -1. These are some good ones that come up in a lot of reactions. They're relatively abundant. They're near the top of the periodic table. These are 4 really good ones to memorize. All right, I'll have you answer a few more here, but that's that for this lecture video. Have a good rest of your day.